Today we're going to learn how to graph quadratics. I mean, it's pretty easy because your calculator will do most of it for you, but we're going to look at it from a point of, even if I didn't have a calculator, how would I do it and what does it look like? A quadratic function, and y'all have probably figured this out by now, but it is non-linear. What does that mean? It's not straight at all. It is a nonlinear function that can be written in the standard form of y equals ax squared plus bx plus c. Every quadratic function has a U shape called a parabola, and y'all have probably heard me say that before. Y'all have heard parabola, yes? Yeah. So they're either like a happy face U or an upside down U, which is like a sad face. If the first term of the quadratic is positive, it's going to be a happy face. It's going to open up. If the first term of the quadratic is negative, it's going to be a sad face and open down. So when you're taking your EOC and it says which graph matches this equation, you can literally look. If the first term is positive, it should be a happy face. If it's negative, it should be a sad face. So everybody look at this one. You have a quadratic parent function. Remember how we learned parent function a long time ago? It's like the number one basic quadratic is x squared. So which way is that one going to open? It's going to be a happy face. It's going to open up. So I want you to fill out a table and graph this parent function. So take your calculator and put it in. So it's y equals x squared. And then where am I going to go? Thank you. To the table. All right. So when x is negative 3, what is y? When x is 2, negative 2, y is 4. When x is negative 1, when x is 0, all you're doing is squaring x. All right, go graph that. Quickly get it graphed and draw your line through it. All right, this is called a parent function. Whenever you're asked to compare parabolas, it will probably be compared to y equals x squared. The lowest or highest point is called the vertex. So this point right here is called what? That is called the vertex. It's the lowest or highest point, just depending on if it opens up or down. If it has a highest point, it's called a maximum. If it has a lowest point, it's called a minimum. So what would this one be? This is a minimum because it's a lowest point. The line that passes through the vertex, so the line that passes through this point and divides the parabola into two symmetrical parts is called the axis of symmetry. So I want you to take something and draw a line right there. Notice if I put a line right there, it splits this thing perfectly in half, and if I was to fold it, it would be exactly the same on the left as it is on the right. This is called the axis of symmetry. And you might have to write an equation for that. So what would the equation be for this axis of symmetry? X equals 0. Remember that when you want to write an equation, it's straight up and down or left to right. It's just which axis is it passing through? Well, this one was passing through the x-axis at 0, so it's just x equals 0. All right, do y'all have any questions about the vocabulary you have to know with parabolas and graphing quadratics? All right, so let's go over it. What's a parabola? It's the U shape that the quadratic graph makes. It'll either be a happy face or sad face. What's a vertex? It is the minimum or maximum, yes, of a parabola. And what's an axis of symmetry? The line that cuts it in half, that where if you fold it, it's the same on both sides. All right, flip to the next page. Now we're going to compare graphs. Okay? So first you need to fill in your table for these. So go ahead and put them in your calculator and fill them in. All right, so you should have filled in your tables, yes? All right, so now if you were to graph the parent function, do it in one color and do the other one in another. So the parent function looks like this, and of course it would just keep going. Okay, now that you got it graphed, you can compare them. So if you were to start with the parent function, the one I did in red, and you took it and you made it into this black one, what happened to it? Okay, yes, but how would you compare it? They took it and, everybody look at my fingers. Did they go like this or did they go like that?
Like this.
Okay, so that's called a vertical stretch. Like they stretched it like this, yes? It's called a vertical, so to compare it. So everybody look, this one is the one we started with, my red one. I went like, it's like I took my fingers and I pulled it like that. So I'm pulling it vertically. It's a vertical stretch. Because I'm stretching it up like this. Does that make sense? Yes or no? Yes. All right, what is the domain? Domain is the x's.
-2, -1, 0, 1. Oh, no.
Thank you. All real numbers, because no matter what, it's going to keep slowly getting wider. Yes? All right, what is the range for both of them? Y is greater than or equal to what? 0. All right, what is the axis of symmetry? That's what that means right there. If you want to put x equals 0, good, because it's right there for both of them, yes? Okay, and does it have a minimum or a maximum? Which one? It has a minimum, so it has a minimum. And what is the minimum?
0.
Y equals 0.
Well,
Are we okay? Okay, fill out your next table. Go. Nobody should be talking. Everybody should fill out the next table. Quickly. Okay, the graph is on the next page, so if you'll just kind of open your paper up where you can see both at the same time. Go ahead and graph the parent function first. Once you have the parent function graphed, go ahead and graph the next one. The parent function's y equals x squared. That's the one you're comparing it to. That's the one you started with. All right, if you were to compare these, the first thing it is what? It's a reflection over what? The x-axis. The next thing they did they take it and stretch it up and down, or did they stretch it side to side? So this is a horizontal stretch. Are their domain and ranges going to be the same? No. Will their domain? Yes. So both domains are all real numbers because it's just going to keep getting wider and wider. But the parent function's range is y is greater than or equal to 0. The other one is y is less than or equal to 0 because one's going down and one's going up. Are y'all good with that?
Wait. Back then, I remember we learned a vertical shape. What's that?
That has nothing to do with this lesson.
Oh.
We'll go back over it, though. I don't want to confuse y'all right now. All right, and the last thing is minimum or maximum. So this one has a maximum, and this one has a minimum. How about their axis of symmetry? Is it the same or is it different? It's the same, and what is it? X equals 0. All right, let's do this one. So fill out your table super fast. The parent function is always the same, guys, so you should already have those numbers done. Okay, graph your parent function. Graph your other function. All right, did y'all get it graphed? Let's compare them. Did it stretch it or shrink it, or did it? No. Nope. It didn't do anything to it, did it? It didn't do this. It's not thinner, and it's not wider. So what did it do? It translated it up 5. It basically just took this whole thing and pushed it up. So its comparison is that it translated just means moved, up 5 units, or up 5. Do y'all get it? Do y'all see that over here it it horizontally pulled it apart and made it wider. These are the exact same size. They're not shrunk or anything. It's just pushed up. Translated it up 5. All right. What is their domain? All real numbers. Are their ranges the same? No. So for my red one, my range is y is greater than or equal to 0. But for my black one, it's y is greater than or equal to 5. All right, let's talk about the axis of symmetry. Oh, let's talk about the vertex because we haven't talked about that. What's the vertex for the red one? Like, give me a coordinate. 0, 0. What's the vertex for my black one? 0, 5. And just so y'all know, if they give you the vertex, the x coordinate is your axis of symmetry. So see right here, that's your x equals 0. You'll see how it's the same for both. That's your axis of symmetry. And then the second number will tell you your minimum or maximum. So this tells you here you have a minimum of 0 and here you have a minimum of 5. Just a different way to look at it. If they give you the vertex will tell you the axis of symmetry and the minimum or maximum. All right, turn the page. Oh, before y'all turn, I just want y'all to look. So when we did up here, y'all can just look with me. If I have a parent function of x squared and I multiply it by 3, it did a vertical stretch, yes? If I multiplied it by a negative fraction, it flipped it. The negative made it flip, but the fraction made it do a horizontal stretch. Do y'all see the difference? Here, I didn't do anything to the parent function. I didn't multiply it. Y'all see x squared is the same as x squared. But I added 5 to the right of it, which pushed it up 5 units. Does that make sense? But you don't have to memorize any of that. Your calculator will, you just push it in and it'll see what happened. So everybody look at this one. We took the parent function, we multiplied by a half. It's going to make it stretch out wider, right? And then we did a minus 4. So not only are we going to stretch it wide, we're going to pull it down. Make sense? All right, so if you want to put this one in, you can. You should already know the parent function is going to be 4, 1, 0, 1, 4. Quiet. So does everybody see what I was saying? This number right here that we multiplied it by 1/2 made it horizontally stretch. Yes? And this number right here shifted it down 4 units. So do y'all know how to compare? What would I write for the comparison? So horizontal stretch. Is that it? And it translated down 4. Okay, this one has a vertex of 0, 0. This one has a vertex of 0, negative 4. Yes? They both have minimums. Their domains are the same, all real numbers, but their ranges are different, right? This one's range is y is greater than or equal to.
What?
0.
This one's range is y is greater than or equal to.
0.
And this one's range is y is greater than or equal to negative 4. Good. All right, let's answer these last 2 questions.
What's the choice?
Yep, this is how they kind of might be asked on like an EOC. It says, how would the graph of the function y equals x squared plus 5 be affected if the function were changed to y equals x squared plus 3? So everybody look at the first number. Did anything change there? No, so it would not be a vertical stretch or horizontal stretch. Okay, but everybody look at the second number. This one's going to be up at positive 5, and this one's going to be up at positive 3. This is the one you started with, right? So if I graphed it, just so y'all can see, this one's going to be 1, 2, 3, 4, 5. It's going to be right here, and it's going to look like that. Everybody agree? This one's going to be right here at 1, 2, 3, and it's going to look the exact same. So what happened to it? It shifted down 2 units. All right, the next question. How would the graph of the function y equals x squared minus 3 be affected if the function were changed to y equals a number times x squared minus 2? So let's just, since we're only worried about up and down, let's not worry about that number, okay? So if I had a graph, this one's going to start where? A -3. And it's going to be up a happy face because that's positive. Does everybody agree? All right, this one's going to be at -2. It's going to be a happy face. So which way did it shift? Up 1. All right, let me pass that. All right, at the top, all you have to do is complete the table. Literally, the calculator will do the work for you. Just write the answers right underneath where it should go. I don't like how they put question marks either. I'd rather just fill it in. But just put it right below where it should be. Everybody good? Number 5, 6, and 7 says match the function with its graph. Well, you already know that if the function has a negative coefficient to x squared, it's going to be a sad face, right? So that should already help you with that.
Oh, you already told us that.
All right. Number 8, 9, and 10, let's talk about it. It says graph the function. That's one question, graphing it. The next question says identify the domain and the range. So you need the domain and you need the range. So for this one, I would go graph 5x squared. It would look like this. It's that simple. The domain is all real numbers. The range is y is greater than or equal to 0. Am I done?
No.
No.
What?
Now it says
Oh.
compare the graph. I'm comparing this one to y equals x squared. Well, if you don't want to have to graph x squared, you can literally go look and say, hey, what happened when we took x squared and we added a big number for the coefficient? What happened? It was a vertical. Yeah, you can kind of look at your notes. So this would be a vertical stretch. And that's it. It didn't flip it across the x-axis or anything. This one's going to flip it, isn't it? Because of that negative, right? And that's going to be a horizontal stretch. This one's going to be a flip and a vertical stretch. All right, 11 through 13 says identify the vertex and axis of symmetry. The vertex is a coordinate. So for this one, my vertex is right here. So what are they counting by? Okay, so what is this coordinate?
0.
So that's your vertex. And my axis of symmetry is x equals 0. So 2 answers for that part. Is everybody good with that?
Yes.
Okay, flip to the back. This says match the function with its graph. I mean, your calculator will do it for you. You also know that this number is going to be the what? That's your y-intercept.
Yes.
Okay? The next section says graph the function, so that's part 1. You got to go graph it. The next part says identify the domain and range. So you need a D, domain, R, range. And then compare again. This one's going to be a what? Translated? Down 5. Okay, so you got to do your comparison. So that has 1, 2, 3, 4 questions in it. It's very easy. That'll be good, 1 through 19. The rest is easy, but I won't make y'all do it. Just do 1 through 19. All right, get busy. You have some time to work on it.